So let us see the varying LED brightness corresponding to given input. So right now I'm going to start with input 0, that is I have given binary 0000. There is no illumination in the LED, but as soon as I'm going to give 1, that is binary 1 as well as decimal 1, the LED is going to light up very weak. But as I'm going to increase the input, that is right now I have given 0011, that is 3, so LED has become little bit more brighter. But again if I change the input to 0011, so again the LED will become less bright. Now I'm going to even bright it further by giving 0111, that is 7, so you can change the corresponding, you can see the corresponding change in the brightness. So like right now I'm going to give it maximum input that can be possible with the 4-bit binary input, so that is 1111. With that I am getting the brightest LED as possible on this board. This was a Xilinx FPGA Spartan 6 board, and this is the actually what we are trying to do is we are trying to give varying pulse width at a given digital port, that is LED 0, and LED 0 is taken at pin number 16, and these switches are taken from pin number 80 to pin number 83, corresponding to um, MSB and LSB. We are just taking a pulse of as the clock is generated of 10 megahertz, so we are taking a pulse of zero point 0.1 microsecond and dividing it with a counter of approximately 480. So we have segmented the counter in interval of 30. So with that, the corresponding counter value increments by 30 in next input. For example, the first input start with 0000, and the corresponding counter value is 30. But when I give counter value as 60, the an input changes to 2, binary 2. Then next value is achieved, and that value of pulse width is given to digital pin of LED 0. So in that case, we are varying the pulse and giving it to digital input of LED connection, and with that we are achieving different intensity or brightness of LED corresponding to different width of pulses that are fed into that digital port, by just varying the input. As input are varying, the width of the pulse, analog pulse that are associated, is changing, and that varying pulse is fed to um, LED. And since the pulse is varying, so the DC power associated with that pulse is also varying, and that DC power is given to digital pin. And since the clock is very high frequency, so we are unable to see that toggling or shifting of that pulses, clock pulses in real eyes, but that can be seen only as a difference of intensity with the corresponding um, clocks. For example, again I'm showing you the intensity that is given corresponding to binary input 0001, but as soon as I give 15, the LED becomes the brightest which can be possibly achieved. And again it is coming in the mid range when the input of 8 is given to it.